Hi everyone, this is Arvind from Mindmajix, and today I welcome you all to this amazing session on SRE Azure interview questions. So, guys, a few weeks back, we had recorded one video with SRE AWS interview questions, and after that video, we decided to come up with the Azure version of SRE as well, because you must be knowing that the AWS and Azure, these are the one of the top players in cloud service providers. Okay, so that is the whole agenda for this video. So in this video we will be covering the most frequently asked SRE Azure interview questions. Like you all know, for the interview questions we have 30 questions, and all those 30 questions are divided into three categories. Like the first 10 questions are for the beginners, or the freshers, and the next 10 questions are for the intermediate candidates, like those people who have at least 2 to 3 years of experience of working into the SRE Azure domain. And the last 10 questions are for the advanced people, like those people who have a more significant experience, let's say like 4 to 5 years of experience of working into SRE Azure domain. So this is the agenda for this video, and before moving ahead, I want you guys to subscribe to Mindmajix YouTube channel and also hit that bell icon so that you never miss an update from us. Okay, so without any further delay, let's get started with our first question. Okay, so the first question is a very basic and very obvious question. What is the role of an SRE in Azure? Okay, so an Azure SRE's role is to bridge the gap between the development and the operations by ensuring that the applications are reliable, scalable, secure, and cost effective. Basically, they focus on automation, monitoring, incident response, and capacity planning rather than manual firefighting. For example, instead of manually restarting a VM when it goes down, an SRE builds an auto healing mechanism using the Azure Monitor and Logic apps. Apart from this, they also define the SLOs, SLIs, and error budgets to balance the reliability with the new feature delivery. So, in short, SREs ensure that the services running in Azure meet both business and customer expectations while minimizing the downtime and the performance issues. So this was a quick overview of what exactly is the role of an SRE in Azure. So now let's move to the next question. And the next question is, what are the availability zones in Azure? So basically, the availability zones are physically separate data centers within an Azure region. So each with its own independent power, cooling, and networking. They are in fact designed to provide fault isolation so that if one zone goes down, the applications in other zones continue running. As an SRE, what is your job? So basically what you would do is you would distribute workloads across zones to ensure high availability. For example, deploying an Azure SQL database with zone redundancy ensures that it remains available even if one zone experiences a failure. So basically, availability zones are key for designing business continuity solutions without having to rely on cross-region setups unless required. So let's move to the next question. And the next question says, how do you monitor applications in Azure? So monitoring in Azure is basically done using tools like Azure Monitor, Application Insights, and Log Analytics. So Azure Monitor collects metrics such as CPU, memory, and disk utilization, while Application Insights tracks the application performance, user behavior, and request failures. On the other hand, Log Analytics provides a centralized log store where you can run Custo query language, or the KQL queries, to identify the root causes. For example, if a web app is experiencing latency, Application Insights can show whether the slowdown is caused by backend APIs, database queries, or external dependencies. So, a good monitoring strategy ensures end to end visibility and helps you detect the issues before they impact the users. The next question is, what is Azure Service Health? So Azure Service Health is a personalized dashboard that alerts you when Azure services are experiencing outages, planned maintenance, or degraded performance. It is especially important because issues at the Azure platform level may not show up in your monitoring tools. For example, if there's a networking issue in the US East region affecting the Azure VMs, So service health notifies you so that you don't waste time debugging your application. Apart from this, it also provides root cause analysis or the RCA reports after the incidents, which help in post incident reviews. From an SRE perspective, service health is critical for incident management and customer communication. So guys, the next question over here is a scenario based question. So basically in actual interview, what happens is, apart from the theory questions, they are also going to ask you, scenario based question. And these are the questions that are asked in order to evaluate the applicant's practical knowledge. Okay. So this question, like I told you, is a scenario based question. And the question says, your Azure VM crashed due to high CPU utilization. So if you experience these kind of situation, what are the steps that you would take to solve this particular problem? So firstly, what you would do is you want to check the Azure monitor metrics to confirm whether the CPU spike was sudden or a long-term trend. After that, what would be the next step? So the next step would be to log into the VM using the Azure Bastion or the RDP to inspect the running processes and the application that are consuming the resources. So if it's the workload related, you might recommend scaling up to a larger VM SKU or using the VM scale sets with auto scaling. So if the spike was caused by inefficient application code, you would escalate to the dev team for optimization. Apart from this, you would also set Azure alerts for CPU thresholds to proactively catch the future issues as well. The long-term fix would be auto-scaling rules so that the VM adjusts automatically based on the demand. Okay, so guys, the next question is, what is Azure Resource Manager or the ARM? So Azure Resource Manager or ARM is the management layer that allows you to deploy, manage, and organize Azure resources through templates, APIs, and role-based access control. So with ARM, the infrastructure can be defined as code using the JSON or the bicep templates, ensuring consistency and repeatability as well. So for example, instead of manually creating 10 VMs, an SRE can use a single ARM template to deploy all of the VMs with identical configurations in minutes. Apart from this, ARM also supports features like resource tagging for cost tracking and policy enforcement. So basically, this reduces the manual errors, enforces standards, and allows for automation in the CI/CD pipelines. So guys, the next question is again a scenario based question. So this question says, let's suppose your web app hosted in Azure App Service is running slowly. So how do you troubleshoot this particular situation? So first and foremost, what you can do is you can start by checking the application insights to analyze the response times, failed requests, and the dependency performance. If the app service plan is under heavy load, what you can do is you can check the CPU, memory, and connection limits. The next step would be to use the app service diagnostics tool for deeper insights into app performance and the configuration issues. So if the root cause is the database, what you can do is you can look at the query performance and connection pooling. As an immediate fix, what you can do is you can scale up the app service plan to a higher tier or enable the auto scaling. So for long-term stability, what you can do is you can implement performance monitoring dashboards to detect early warnings. The next question is, what is the difference between Azure Monitor and the log analytics? So Azure Monitor is a comprehensive monitoring platform that collects telemetry data such as metrics, logs, traces from across Azure resources. On the other hand, log analytics is a specialized tool inside Azure Monitor that allows querying and analyzing those logs using the KQL or the Custo query language. For example, Azure Monitor may show that a VM's CPU is consistently above 80%, while log analytics helps you determine which process or the user is responsible for it. Essentially, Monitor is for collecting and visualizing data, while log analytics is for deep investigation and correlation. So together, they can provide end-to-end observability for troubleshooting and optimization purpose. The next question is, a scenario-based question, and the question says, how would you design a highly available application in Azure? So first and foremost, what you can do is you can use a multi-zone or a multi-region deployment to ensure the redundancy. Next, for the front end, what you can do is you can place an Azure load balancer or the application gateway to distribute traffic across multiple instances. So for global applications, what you can do is you can add Azure Traffic Manager or front door for geo-redundant routing. For the purpose of data, what you can use is you can use geo-replicated databases like Azure SQL with failover groups or Cosmos DB with multi-region writes. Apart from this, what you can do is you can implement automated backups and disaster recovery policies as well. So this ensures that even if a zone or a region fails, that the application continues to run with minimal amount of downtime. The next question is, what is Azure Application Gateway and how is it useful for SREs? So Azure Application Gateway is a layer 7 load balancer with advanced features such as SSL termination, URL based routing, and web application firewall. For SREs, it ensures secure, scalable, and reliable traffic management. For example, if one backend service is unhealthy, the application gateway automatically reroutes requests to the healthy instances. It can also be configured to block malicious traffic like SQL injection or cross-site scripting. So this reduces operational overhead, improves security posture, and ensures a smooth end user experience even under high traffic. So guys, with this we have covered the beginner level questions for SRE Azure, and now question number 11 to 20. These are the questions that are meant for the intermediate people. So the next question is, how does Azure autoscale work? So basically, Azure autoscale dynamically adjusts the resources in response to the demand. So it uses metrics like CPU utilization, memory consumption, or queue length to trigger scaling actions. For example, an Azure App Service plan can be set to scale out when CPU stays above 70% for 10 minutes and scale in when it drops below 30%. So this ensures consistent performance during peak usage and cost savings during low usage. Autoscale also supports time-based tools such as adding more instances during business hours and scaling down at night. So from an SRE perspective, autoscale reduces manual intervention and improves the service resilience by automatically handling the traffic fluctuations. The next question is a scenario-based question. So let's say your Azure Kubernetes service or the AKS pods keep crashing. So how would you troubleshoot this particular situation? So first and foremost, what you can do is you can start by checking the pod logs and the events using the kubectl logs and the kubectl describe to identify the cause. After that, what you can do is you can review the Azure monitor for containers to analyze the node health, memory or the CPU usage, and container restart count. So if the issue is due to the insufficient resources, what you can do is you can adjust the resource requests and limits in the pod configuration. So if it's related to a faulty image, you would roll back to the latest known stable version. After that, you can also confirm whether the readiness and the liveness probes are configured properly, since incorrect settings can trigger false restarts. So for long-term stability, you can implement pod distribution budgets and horizontal pod autoscaling. The next question is, how do you handle incident management as an Azure SRE? So incident management basically involves detecting, triaging, and mitigating and documenting the incidents. So first step, what you can do is you can rely on Azure Monitor alerts, log analytics queries, and dashboards to detect the anomalies quickly. So once detected, you would triage by checking the services and the customers that are affected and prioritize them based on the impact. For mitigation, you can use the solutions like Traffic Manager Failover or scaling the resources to stabilize the system. So after the resolution, you can conduct a post-incident review or the PIR, including the root cause analysis and the action items. For example, if a VM scale set kept crashing, the PIR might recommend implementing auto healing or moving the workloads to a managed service. The next question is, what is Azure Front Door and how is it different from Application Gateway? So Azure Front Door is a global entry point for web applications that provide load balancing, routing, acceleration, and security at the edge. So basically, it routes the user traffic to the nearest available backend, reducing the latency and improving the reliability. Application Gateway, on the other hand, is regional and best suited for internal and single region applications. For example, a global e-commerce website might use the front door for global traffic distribution and then use the application gateway within each region for application level routing and the WAF protection. So from an SRE perspective, combining both helps achieve low latency, high availability, and strong security. So guys, the next question is a scenario based question. So the question says your application hosted in Azure is experiencing high latency. So how would you diagnose this? So basically over here, what you can do is you can begin by checking the Azure Monitor and Application Insights for performance bottlenecks across the services. After that, you can use the Azure Network Watcher to analyze the network latency, packet loss, or misconfigured NSGs. If the issue is at the database level, you can review the Azure SQL Query Performance Insights to check the slow running queries. So to isolate the issues, what you can do is you can run end-to-end tracing with application insights to see where requests are slowing down. So if it is region specific, what you can do is you can redirect the users using the Azure front door to a healthier region. So the long-term solution would be recommending caching strategies and scaling critical services to reduce the latency. The next question is, what are SLAs, SLOs, and SLIs in SRE practice? So basically, SLA is the service level agreement. So this is basically a contractual uptime commitment to customers. For example, 99.95% availability for Azure SQL. Now, if you talk about the SLO, it is basically the service level objective. So this is an internal target for reliability. For example, 99.99% uptime. And then comes the SLI or the service level indicator. So this is a measurable metric. For example, 99.9% successful requests or less than 200 of milliseconds of latency. For example, if a service has a 99.95% SLA, but the team's SLO is 99.99%, then the SLI would track the real world indicators like request success rate or error percentage. So basically, SREs use these metrics to balance the new feature delivery with system reliability. So if error budgets are exhausted, focus shifts from feature rollouts to improving reliability. The next question is a scenario based question. So this question says, so let's suppose you get frequent alerts for minor issues. So how would you reduce the alert fatigue? So basically over here, what you can do is you can start by reviewing the existing alert rules to see which are too sensitive or redundant. After that, you can implement the dynamic thresholds in Azure Monitor so that the alerts are triggered only when deviations are significant compared to the normal baselines. Apart from this, what you can do is you can group the alerts into action groups and set the security levels so that the critical issues are prioritized. For example, instead of alerting every time the CPU is over 70%, what you can do is you can configure it to trigger only if the CPU is greater than 80% for 10 minutes. Apart from this, you can also use separation rules and alert correlation to avoid the duplicate notifications. So this ensures that the SRE focus only on actionable and meaningful incidents. The next question is, what is Azure Chaos Studio and how does it help SREs? So Azure Chaos Studio is a chaos engineering platform that lets you test the system resilience by simulating the real world failures. So it can inject faults such as VM reboots, network latency, or the CPU spikes or service outages. For example, I can simulate a region level outage to verify if my AKS cluster fails over correctly using the traffic manager. So by proactively testing failures, SREs can uncover weaknesses before they impact the customers. Chaos Studio helps the team validate disaster recovery plans, failover mechanisms, and auto-scaling rules. So basically, it's a key tool for building confidence in highly available and fault-tolerant architectures. The next question is, let's suppose you need to reduce the cloud costs without affecting the reliability. So how would you approach this particular situation? So over here, what you can do is you can analyze the Azure cost management and advisor reports to identify the underutilized or idle resources. After that, what you can recommend is reserved instances or savings plans for predictable workloads and auto scaling for variable workloads as well. For example, the dev and the test environments can be scheduled to shut down during the non-working hours to save the costs. Apart from this, you can also optimize the storage by moving the old logs to Azure Blob Storage. And for compute heavy apps, what you can do is you can consider spot VMs if workloads can tolerate the interruptions. So this approach balances the cost savings with reliability by eliminating the waste while keeping the critical services resilient. The next question is, how do you secure Azure infrastructure from an SRE perspective? So security in Azure involves enforcing the principle of least privilege, identity protection, and network security. For that, you can use Azure RBAC and managed identities to avoid the storing of credentials in code itself. Apart from that, secrets and keys would be stored in Azure Key Vault with strict access controls. On the network side, what you can do is you can apply network security groups or NSGs and Azure firewalls or DDoS protection to restrict unwanted traffic. So for compliance, you would enable Azure security centers and policies to enforce the best practices. So from an SRE perspective, these measures not only protect the application, but they also reduce the downtime risks from attacks or misconfigurations. So guys, with this, we have covered the intermediate level questions for SRE Azure. And now question number 21 to 30, we will be covering a few advanced questions. And the next question says, how do you design a disaster recovery strategy in Azure? A DR strategy or a disaster recovery strategy in Azure basically requires planning for redundancy, failover, and recovery times. For that, what you can do is you can use geo-redundant storage or the GRS, cross-region replication, and Azure Site Recovery for VMs. So for databases, what you can do is you can configure auto failover groups in Azure SQL or use the Cosmos DB multi-region replication. So traffic would be managed via Azure Traffic Manager or front door to reroute users automatically. Apart from this, you can also define the RPO or the recovery point object and the RTO or the recovery time objective to set the realistic recovery goals. So regular DR drills are essential to validate that the failover works as intended. The goal is basically to minimize the downtime and the data loss in case of regional outages. The next question is, let's say you have a critical AKS workload that must survive a regional outage. So how would you design this particular AKS? So basically, what you can do is you can deploy AKS clusters in two different regions and use Azure Front Door to distribute the traffic globally. So for container images, you would enable the Azure Container Registry geo replication so that both of the clusters have access to the same images. Persistent data would be stored in geo-replicated database such as the Cosmos DB or the Azure SQL with failover groups. Apart from that, you can configure the multi-region ingress controllers to ensure that the requests are routed correctly even if one region fails. So during the failover, traffic automatically shifts to the healthy region with minimal disruption. So this setup ensures business continuity even during the large-scale outages. The next question is, how do you use infrastructure as code or IAC in Azure for reliability? So infrastructure as code or IAC basically ensures consistency, repeatability, and automation in managing the infrastructure. So in Azure, you can use Bicep, ARM templates, or Terraform to define the resources declaratively. So this way, the infrastructure can be version controlled, peer reviewed, and automatically deployed through the CI/CD pipelines. For example, if a region goes down, the same IAC template can be applied in a secondary region to rebuild the infrastructure quickly. Apart from this, IAC can also enable the policy enforcement and compliance by embedding the security standards into templates. So for SREs, The IAC reduces configuration drift and allows faster recovery during outages. The next question is, let's say your production app had a downtime due to a misconfigured deployment. So how would you prevent this thing to happen in future? So first of all, you can implement safe deployment practices like the blue-green or the canary deployments. So with the blue-green, two environments run in parallel and the traffic switches only after validation. On the other hand, canary allows a small percentage of users to get the new release, reducing the blast radius if the issues occur. Apart from this, you can also enforce infrastructure as code reviews and automated tests before deployment. For example, Helm charts in AKS could be validated in staging cluster before a rollout. Additionally, what you can do is you can integrate Azure DevOps pipelines with approval gates to ensure only validated code reaches the production. So this basically reduces the human error and deployment related outages. The next question is, what are error budgets and how would you apply them in Azure SRE? So an error budget is the maximum allowable downtime or errors within an SLO period. For example, if the SLO is 99.9%, the error budget allows 43 minutes of downtime per month. So if the service operates within the budget, the team can release new features freely. If the budget is exhausted, releases pause and reliability improvements take the priority. For instance, if frequent outages consume the error budget, you can recommend stabilization sprints focused on fixing the root causes. Basically, error budgets helps the balance of the innovation with reliability and provide a data-driven way to make the trade-offs. The next question is a scenario-based question. So let's say a spike in traffic caused your Azure API management service to throttle the requests. How would you fix this problem? So first and foremost, you can analyze APIM analytics to identify which APIs or clients are generating excess traffic. So if they are legitimate, you can use or you can scale APIM units to handle more requests. If certain clients are misbehaving, then what you can do is you can configure the rate limits, quotas or subscription keys to protect the backend services. Apart from this, you can also consider caching responses for heavy read operations using the APIM or the Azure CDN. So for long-term resilience, you can set up autoscaling for APIM if the SKU supports it. So this basically ensures that the system can handle these spikes without compromising the reliability. The next question is, how do you handle multi-cloud reliability when Azure is one of the providers? So basically, multi-cloud reliability involves building cloud agnostic applications that can run across providers like Azure, AWS, GCP, and so on. For that, what you can do is you can use Kubernetes for container orchestration and CI/CD pipelines that support the multiple platform. For global traffic routing, what you can do is you can use DNS-based failover solutions with providers like Azure Traffic Manager. For example, the same microservice architecture could run on AKS, EKS with a shared database replication strategy. Over here, monitoring tools like Prometheus plus Grafana or Azure Monitor with exporters can centralize the observability. So basically, the end goal over here is to reduce the vendor lock-in while ensuring resilience across providers. The next question is, let's suppose your Azure SQL database is hitting the DTU limits frequently. So how do you optimize this? So first and foremost, you can start with query performance insights to identify slow or resource heavy queries. Over here, indexing and query optimization would be the ideal first step. So if workload demands are unpredictable, you can consider moving from a DTU based to a vCore based pricing, which allows more flexibility. So for large scale workloads, you might recommend hyperscale SQL to handle the high concurrency. Apart from that, you can also implement caching using the Azure Cache for Redis to reduce the database load. For scaling purpose, scaling vertically or enabling auto pause resume for certain workloads can also optimize the costs and the performance. The next question is, how do you ensure observability in complex Azure microservices architecture? So observability in microservices requires collecting metrics, logs, and traces across services. So over here, what you can do is you can use Azure Monitor for metrics, log analytics for logs, and application insights for distributed tracing. For example, when a user request fails, tracing can show whether it broke in the API layer, payment service, or database call. For that, you can use correlation IDs to link the logs across microservices. The dashboards and the alerts would be configured to provide the real-time visibility. And observability enables faster root cause analysis and proactive incident management in a distributed system. The next question is, let's suppose during a regional outage, your failover didn't work as expected. So how do you improve the resilience? So first and foremost, you can conduct a post-incident analysis to identify why the failover failed, possibly due to the missing health probes, misconfigured traffic manager rules, or dependencies not replicated cross-region. After that, you can implement automated failover tests using the Azure Chaos Studio to validate the configurations. So all the critical dependencies like the databases, caches, and storage would be geo-replicated. Apart from this, you can also improve monitoring by adding the alerts for failover readiness. Finally, you can schedule regular DR drills to ensure that the teams and the systems are prepared for real outages. Over here, continuous testing ensures that the resilience becomes a living and tested part of the architecture. So guys, with this we have covered the most frequently asked SRE Azure interview questions. I hope you guys have enjoyed this session. If at all you have any doubts or queries related to this session, then you can write them in the comment section and we will try to resolve your doubts and queries as soon as possible. So guys, thank you so much for being with us and I wish you all the very best for your upcoming interview.